Alright, today we are doing base E and natural logs. Alright, I know it's been a while since we've done something new, but we're almost done. After this, we only have two more things to do on the year, and we're done. Alright, so we are doing base E, natural logs. We're continuing logs. It says, what is E? E is an irrational number with an approximate value of 2.71828. All right. So E is an irrational number with an approximate value of 2.71828. E often occurs as the base of exponential and log functions that describe real-world scenarios. All right. So you'll see when we're talking real-world examples, you might see that base E. And then it says base E exponential functions. Exponential functions with the base E are called natural base exponential functions. An example of this is f of x equals e to the power of x. All right, so it says exponential functions with base e are called natural base, or natural bases. Natural base exponential functions, sorry. An example of that is f of x equals e to the power of x. All right, hopefully we have that. Then it says log functions with base e are called natural log. Or you can write out logarithmic. All right, an example of this is f of x equals log e of x. This is often abbreviated as f of x. F of x equals ln x. So if you see that, that's the same thing. All right, and converting is kind of like what we did on that last test. Converting is still the same. You'll see how we're going from exponential equation to log form and log form to exponential form. All right, so I'm only going to do a couple of each because, again, this is your assignment. Converting between forms. We see we have for number one, e to the power of x equals 24, and it says write each equation in log form. Again, log the big number, which right here it's an e, so that e becomes small, log e of 24. The 24 moves to the left of the equal sign equals x. So again, this is the same conversion as when we had numbers, when we were going from log to exponent. It's the same thing. This big one right here becomes little. The x and the 24 basically just switch sides, but the 24 stays big. That's it. All right, so looking at number two, I'll do this one again just to make sure we got it. All right, we have e to the power of 9 equals x. So rewritten, log the big E becomes little. The x and the 9 switch sides, so x equals 9, and that's it. All right, that should be really easy. Now for number 4, I'm just going to do number 4. We're going to go from log form to exponential form, so we're going to do the opposite. All right, so we see it's written ln of x equals 58. So rewritten, remember this means there's really an e there, so e, big E, to the power of 58 equals x. That's it. All right, that is it. Now moving on, simplifying with properties. All right, it's the same as what we did before. Plus really means multiplication, and minus really means divide. Okay, so looking at number 7, it says ln 3 plus ln 16. That's really ln 3 times 16. 3 times 16 is 48, so ln 48. And that's it. See how quick that was? All right. That's how we condense. We make it smaller. We started with ln 3 and ln 16, and we ended up with ln 48. All right. And on number 10, it says expand. So we see it's ln 5x, or think about it as ln 5 times x. So that's really ln 5 plus ln and x, and we're done. See what I mean? This is just like what we did a couple weeks ago, where we were expanding and condensing and simplifying. This is it, y'all. All right. Let's see if we need to do one more in the back. Yes, we do, because down here we're solving. We are solving equations. This paper is basically, with E, it's like putting everything together that we've already done. We did simplifying, we did expanding, we did condensing, and we did solving. We did solving just last week. All right? Solving, remember, when the base is the same, we can just ignore it. So we'll take 4x minus 27, and that's equal to 15 minus 2x. All right? So now we solve. Plus 2x plus 2x. All right, that's 6x. That's on this side, so we got to add the 27 plus 27 over here. So 6x equals 15 plus 27 is 42. Now this is easy. Finish it out. Divide by 6, divide by 6. X equals 7. And we're done. That's how we solve. Okay, remember, you might have to condense. All right, like here on number 14, we send this 2. Remember, that's the power property. So we send this 2 to the k. So it's really k squared equals 2k plus 15. From there, don't say, oh, I'm going to combine the k squared and the 2k. No, you can't do that. You got to move everything to one side. So we have k squared minus 2k minus 15. And then from there, with 3 things, we know we have to factor it out. We should know how to factor by now. We've been factoring for months. So that's just a little hint. I know we might have had some questions on the last one. What do you do in that situation? Don't combine k squared and 2k. That's not the same thing. They're not like terms. We should know that. So we have to move everything on one side. And then from there, with a trinomial, which means 3 things, you know when you see a trinomial, you got to factor it out. All right? Finish the rest of it on your own. Turn it in. Get it done.